Hello and welcome back to the Make Retro Games with Benny channel. My name is Benny Lindstedt, and in this second episode we're gonna set up a plan for what we will create, what game we will create. So please join me on this journey. Okay. Let's see. What's the plan? Yeah, what's the plan? What are we going to build? If we're going to create the game, then we for sure need to have some idea on what to create. And the first thing to do is to come up with a plan and write some notes on what we're about to create, and also do some writing simple mockups or wireframes or whatever. As you see here in this picture, I have done a simple sketch over what this game is supposed to look like, and it's called Fetcher. But more on this later. Let's see the next slide here. Yeah, first of all, you need to have some kind of name of or first of all, but one of the things you need to come up with is a name. And it should be something that's sort of related to the game. At least that's what I think it should. And then you should actually write in plain English a description of what is this game about. And you can also do some graphical mockups, as you saw in the previous slide, and we will see it more later. These sort of, it's not that it needs to be done with some sort of description first and then the mockup. You can do them in parallel, but they both sort of help each other. So it's easier if you have some drawings and then you write some write some text and then you do some more drawings maybe till you have something that you feel that okay, yeah, this is what I want. And when that's done, you can dig a little bit deeper in sort of the sequence of what's going to happen in the game, and that's the create a list of activities, sort of the flow in the game. And here you should list the important features, and you should sort of step by step go through the game. But it helps to think of things like what's the aim of the game? Yeah, and you have already written that in the description, most probably. And it's but just to get the flow starting in your mind, you can sort of think of these things, and you can also identify and isolate problems. If you find something during your process in your brain, you can sort of, okay, yeah, I know this might be a problem in the future, so then you just type it down so you can dig a little bit deeper into it later on. Yeah, and that goes also for the mechanics in the game. It could be like how will I steer my character? What's the character? What's the sort of what can the character do? Crawl, jump, yeah, whatever. But then you also could sort of decide on a little bit writing how to steer it. Is it joystick or mouse or whatever? Yeah, and after that, you could also write some non-functional requirements, and this goes hand in hand with the above activities. And if you have written down some information regarding, yeah, in my character should be a sprite with 16 colors, then you can here in this non-functional requirements part, you can sort of list what colors or what sizes you will have. And then you're pretty much done with the basic specifications that you need. Of course, you can go back and iterate through those from time to time, but I think it's mostly interesting before you have actually started to do the coding. And when you have sort of went over to the code, then it's not so fun anymore to do specifications. But I think it's really good to do this up front. It will not maybe take more than 10 or 15 minutes to do this, and that's why I think it's worth it, because you will actually think things through, and it's easier than when you actually do the coding. Yeah, and then the last bullet I have here is you should split the program into components. It's maybe not part of the specification really, but that's sort of the next step here. Sort of, yeah, how will I divide my program? And the good thing with code is that it's pretty much the same setup for each game. So that's the sort of easy part with the game if you compare to another solution that sort of involves a database, and you have a middle layer and you have a front end, and you can do it in maybe 20 different ways. But in gaming, it's more like, yeah, you have this game loop, and that's where you do all the stuff. Of course, it will be much more code for a larger game, but sort of the basic structure in a game is pretty much the same all the time. And that's why you also have these gaming or like Unity and game engines. They are sort of based on that you have this game loop in the sort of all your games. And then they could sort of abstract that away so you don't even see it, but it is there. On the other hand, what's sort of the other part of making a game is that it's actually much harder than making a system, because you have to be like a Swiss Army knife and do everything. At least if you're on your own creating a game, you need to do the graphics, the coding, the music, the sound effects, everything. So you have to be wider maybe in your sort of knowledge base than if you're just doing the sort of the API in some kind of a backend system. Yeah, then you're sort of, yeah, I am an expert on creating APIs, but I have no idea how to create a front end. So that's sort of the part that it's harder on creating a game than like a normal system. But that's also the fun part. At least that's what I think. Doing all those things and sort of make it as a whole thing that you have created by your own. That's sort of a really fun part. Okay, so let's go to the next slide. And I have actually come up with a game idea called Fetcher. Something really simple, just for us to have something to work with. Oops. And then I started to do a description. So I will actually read it through. This game aims for the player to fetch with a mouse randomly positioned balls as fast as possible. there will be 10 balls in different colors for the player to fetch. There should be 2 high scores, one for fastest fetched ball and one for fastest fetched 10 balls. Optionally, the high score lists will be saved on disk. And if you do that, you also need to be able to type in a name. Quite simple, but at least it's a description, and I hope it sort of fetches the goal of the game. Yeah. So next slide. I've also done a mock-up, and you saw it on the first slide also, a miniature of this one. We have sort of up here a UI part where we have the scores, and we have the name, and you see this will be its own screen, this small part, and then we have a larger area here, that's the game field here, and then we have sort of the fetcher. It's this little thing over here, and that will be controlled by the mouse. And then we have 10 balls down here, and each one of those will be randomly put up here, and then you will try as fast as possible to fetch the balls. And as soon as the ball is fetched, it will disappear. And then you will see how fast you fetched it. Pretty simple, but yeah, you understand what I'm about to do here. Next slide. Here comes the activities then. And this is then a little bit more detailed than the first description. So once again, at the start, the player will have 10 balls with different colors. They are placed in a separate screen below the game field. Each ball is a bob, I have written here. Yeah, I think that's the easiest way to solve this. At the start of the game, there will be a text saying, press any key to start game. When player press a key, the first of the 10 balls will be randomly positioned in the game field. The player will control the fetcher with the mouse, as I said before, and the fetcher will be a sprite, and that's because the mouse actually have a little bit different coordinates than a bob. The bob uses sort of screen coordinates, but the mouse uses hardware coordinates, and a sprite also uses hardware coordinates. So it's easy to put the mouse and the sprite together. I will come to that later. Well, the design of the fetcher is actually part of sprites that are included in the Amos Pro that we have already installed. If you follow my first episode, there we installed Amos on an emulator, so you can look into that if you haven't done that before. And as part of that Amos package, then you will have these sprites here. So that's what we're going to use, and I have also written here, is this a good size? Is it too small? Is it too big? Then the player tries to reach the ball with a fetcher as soon as possible, and as soon as the ball is reached, the ball will disappear, and the next ball will be randomly positioned in the game field. And then we need to use sprite to bob collision. That's a command that we use in Amos to see if we have actually hit the ball with the fetcher. And then we have some fetch time results, as I told you before, and they will be shown on top of the game field screen. That's the UI part of the whole game. And I think it's enough to just have 4 colors on this one, because it's only text and the name of the game up there. And you see there will be different high scores and etc. for different things. And then when the game is over, there will be a game over window shown. and that will happen when all 10 balls are fetched. And it's also you can quit the game there, but you can also just start all over again to have another round. And then optionally we will save the high score on disk so we can pick it up at a later time. Yeah, that's pretty much it. And then if we go over to the non-functional requirements, you see here it's just boring information, but I think it's good actually to write it down so you think about it at least. This is maybe not the truth when you have tried it out, but at least you have a plan for it. We have the first on top score screen, it's just 32 pixels wide. And then we have the 180 wide. It's not wide, it's height. Sorry, 320. Everyone here is 320 wide. And then the large game field screen is 192 pixels high because I'm using the PAL system. If you're using NTSC, then you have to change this to something else. I don't know what, but you will figure it out. And then you see it, I have written down background color, etc. The palette is something that we will reuse from the sprite that we picked up from the Amos disk. So we will not create those ourselves, at least not on screen 2 and screen 3. We will then reuse this sprite palette. I will show you how that works later on. But on the top screen, we only have 4 colors, and then we have to hard code those in. Yep. And then when we are done with all those things, we come closer to the code. We start to think about what we're actually going to do in the code. Okay, and as I said before, this is more or less the same for each game you will create. It doesn't matter if it's a huge game or if it's a small game. You still have to have some kind of initialization. You have the game loop that will run during the whole game. And for an Amiga, it runs at 50 times per second. And then when you're done with the game, you have some kind of termination. And then you need to clean up and also present the player an option to play again. So as I said, this is more or less the same. So you can reuse it when you have sort of done it once. You can reuse it for other games. Of course, you need to change it a little bit here and there, but sort of the basic structure will be the same. Okay, and when you have sort of done that, the thing you need to do is this. You need to then sort of divide the code into smaller and smaller sort of components. For an Amiga Amos Basic, you will use mostly procedures or a subroutine. Mostly it's procedures. Sometimes it seems like it's not possible to use them, so you have to use subroutines. But we will get to that when we're sort of getting into the Amos coding. So what I have done here is I actually used these first level of procedures. It's called init, and then I have a game loop that will runs until someone press Q, or in our case we probably should have escape instead, because that's what you usually have. Or if game is, or until game is over, you will run this loop. So what you do is then check input, you move the objects, you detect collisions, you update the score or the UI part. Uh, so it does this for 50 times per second. Uh, and then if you have game over or someone has pressed the Q key, then you will jump down to terminate, and then you will show a game over window. And if the user press quit here, then you will do store on disk, or you will clean up and you shut down the complete game. But however, if the user press that he wants to do another round, then we will start over again and then maybe not do the complete init part here because the sprites are already there. You have opened the screens, but you need to reset the balls down at the bottom, and you need to spawn a new ball in the game field. So it's sort of here you need to jump in, and we will see how we can make that happen later on. And then you see that, okay, I have just written some information on what's supposed to happen on the check input. And so this is actually called pseudocode. It's not really code, but it's more sort of a descriptive language that tells us what to do. It's more like comments. So what I usually do when this part is, well, this is how much I actually do it on paper, and when I come this far, I can sort of take it to the code, and then I leave this as it is. I don't touch it anymore. So the next step for us now is really to put those things into code and then start to divide it even more into smaller pieces, because there might be for move objects, yeah, you can have some subroutines there also, or procedures that help you out. Um, and the same goes for collisions, etc., etc. And you see here, show game over window. Yeah, that will probably be its own process that has some code in it that handle those things. But I haven't sort of described that more because I and you probably understand what we're after here. Yeah. So I think that's it for this episode, and the next time we will do some coding. That would be fun. Take care. Bye.